Now we will do mole concept and molar mass. So mole is defined as the amount of substances. Okay, mole is the unit of amount of substances. Remember, it is defined as the amount of substances that contain as many particles as there are atoms in exactly 12 gram of carbon 12 atom, which means that number of atom present in 12 gram of carbon is known as mole, 1 mole. Okay, so the number of atom present in 12 gram of carbon is 6.022 into 10 to the power 23. So now we are going to calculate this number, that is 1 mole, which is equals to 6.022 into 10 to the power 23. Okay, let us consider one big wall. Okay, let us consider one big wall. Okay, it is made up of brick. Okay, this wall is made up of many bricks. Okay, we don't know the number of brick. So the weight of whole wall is 2000 kg. Just assume it. The weight of the wall is 2000 kg, and the weight of each brick is 2 kg. Now we can calculate the number of brick required to make this wall. Yes or no? So we have 1000 brick. Okay, so 1000 brick is required to make this wall. Similarly, we can find the number of atom in 12 gram of carbon. So we will take atomic mass of carbon, that is 12 gram. Atomic mass of carbon is 12 gram. So mass of one atom of carbon as determined by mass spectrometer is 1.99 into 10 to the power 23 gram. Okay, so number of atom in 12 gram of carbon is given by 12 by 1.99 into 10 to the power minus 23. Okay, if you calculate this, we will get 6.022 into 10 to the power 23. So which means that in 12 gram of carbon there are 6.022 into 10 to the power 23 number of atom. This number is very huge. 6 is multiplied by 10 to the power 23. Just imagine, this number is very huge, and this number is known as Avogadro's number or Avogadro's constant and denoted by Na, and this is constant for all the elements or all the molecules. Okay, if we calculate number of oxygen atom, in 16 gram. Okay, so atomic mass of oxygen is 16 gram. So 16 by, okay, mass of an oxygen atom is 2.6561 into 10 to the power minus 23. So this is the mass of an oxygen atom, and this is the atomic mass of oxygen. If you calculate, we will get 6.023 into 10 to the power 23, same as this. Again, if you calculate number of nitrogen atom present in 14 gram, if you calculate number of nitrogen atom present in 14 gram, you will get same number. Okay, so this number is constant. So this constant number is known as Avogadro's constant. Avogadro's constant, and it is denoted by N, capital N. Okay, so this number is considered as 1 mole. Okay, this number is considered as 1 mole, as 1 dozen means 12, 1 century means 100. Similarly, 1 mole means 6.022 into 10 to the power 23. So this means 1 mole. So collection of 6.022 into 10 to the power 23 particles is termed as 1 mole. Okay, so this number of particles should be present out there to become 1 mole. Okay, done. Take one screenshot and copy afterwards. Okay. Okay, just we have done atomic mass. Atomic mass contain this number of particles, which means 1 mole equals to 6.022 into 10 to the power 23 particles. Okay. Particles means maybe atom, molecules or ions. Okay, per gram atomic mass or gram molecular mass. So this gram atomic mass or gram molecular mass is known as molar mass. Molar mass. So 1 molar mass means in which the number of mole is 1, or the amount of substance in which there exists this number of particles. This number of particles. Okay, the amount of substances in which there exists this number of particles is known as molar mass. So we know that gram atomic mass or gram molecular mass contain this number of particles. Okay, that's why it is known as molar mass. Or let us consider 12 gram of carbon contain 12 gram of carbon atom contain this much of particles. 16 gram of oxygen atom contain this, okay, this much of particles. Therefore 12 gram 16 gram is considered as molar mass. Okay, in case of molecules, okay, take CO2. So molecular mass of CO2 is 44 AMU, or gram molecular mass is 44 gram. Okay, so molar mass of carbon dioxide is 44 gram, as well as gram molecular mass is also 44 gram. These two are always equal. Okay, so 1 mole weight is gram molecular weight or gram atomic weight. Okay, and in case of gas, it will occupy 22.4 liter of volume at standard temperature and pressure at STP. STP means at standard temperature and pressure. Okay, so any gas, okay, 1 mole of any gas occupy 22.4 liter. Remember this thing, 1 mole of any gas occupy 22.4 liter volume at STP, or 2 mole of gas occupy, then 2 mole of gas will occupy 2 into this, 3 mole of gas occupy 3 into 22.4 liter of 4 liter of volume at STP. Remember this thing. And 1 mole or gram molecular weight or 22.4 liter of gas will have 6.022 into 10 to the power 23 number of particles. Particles means atom, molecules or ions. Okay, so these things you should remember very nicely or very clearly. Okay, now I will give you the relation by which you can calculate the number of mole. Okay, so number 1, that is number of moles of atom. If you want to calculate the number of moles of atom, you have to divide it mass of atom by atomic mass. Okay, so number 2, number of moles of molecules will be same as above, mass of molecules divided by molecular mass. Number 3, number of moles of gas. Okay, gas. Volume of that particular gas at STP divided by 22.4 liter, you will get the number of mole. Okay, so this is the given volume. Okay, given volume of gas at STP divided by 22.4 liter, you will get the number of moles of gas. Okay, so these things you have written in your copy, I think so. So take one screenshot, then copy afterwards. Okay, now calculate the number of moles. Calculate the number of moles of the following. Number 1, 88 gram of CO2. Number 2, 460 gram of H2SO4. Okay, number 3, 7.6 gram of iron Number 4. .2 liter of CO2. Okay. So first one I am doing for you. Okay. So CO2 is a molecules. So first of all, what you will do is calculate the molecular mass of CO2, that is C. 12 plus oxygen 16 into 2 atom of oxygen is there. So 12 plus 32 is 44 gram. Okay. So gram molecular mass of CO2 is 44 gram. So here the question is, now calculate the number of moles. So therefore number of moles will be 88. Okay, 88. Mass of a given molecules is 88 gram, and molecular mass is 44 gram. So it will be 2. So the number of moles in 88 gram of CO2 is 2. Okay. Our number of particle present is 2 into 6.022 into 10 to the power 23. So remember this thing. So similarly you can do this. In this case 67.2 liter of CO2, what you will do is just write 67.2. This is the given volume at STP divided by 22.4. You will get the number of moles. Okay. Similarly, this is the same method you have to do here. Okay. Hope you have understood. Any doubt you can write in the comment section. Okay. Or you can send your doubt in the WhatsApp also in the given number. Okay, only this much for today. Thank you so much.